Evening, sir.
Hi JJ, how are you doing?
Good, sir. Just on the road.
Okay.
Sir, I didn't hear you.
No, I'm just saying, okay. I'm just waiting for the others to join.
All right, sir.
hmm
Good evening, everyone.
Evening.
Hello, Morgan. All right, so you're seeing a question that is on the board. I'm calling it early work. I never normally start until about 5:15, but I'm going to ask you to make an attempt and see if we can complete this in short order. Try as best as possible to do this in one sitting, in one go. Thank you. Are we finished with the question now?
So I reached late, so I'm still working. Good evening.
Sir,
No, sir,
almost.
so finish.
All
So
right.
finish.
Is this another 2, 3, 4 minutes?
3.
Three max.
Okay. All right. Your 3 minutes are done. Let's go. Still working?
So I'm gonna get the answer now, but I don't know if it's right.
Okay. Is there anyone still working? Remember, when I ask a question, at a minimum, I should get an answer.
Yes, sir. I said yes.
I
The
didn't
react.
hear you.
It's with the react.
Still
Oh,
here,
with the
sir.
reaction. Crossroad is still working?
Yeah, they're on the move right now still.
Okay. Um,
Let me just reach home.
okay. Adrian, how you stay? Raheem, how you stay?
Finishing in about a minute.
Okay. Orlando, how you stay? Christine, how you stay? Chevy, how you stay? Kino, how you stay?
Yes, sir.
Finish?
Hear me?
Finish?
Yeah, I'm finished, sir. Question, I make sure I'm right. When you say at the point 2 - 1, you got substitute after you differentiate, you got substitute the x and y value with two are -1, right?
Mm-hmm.
All right, good.
So I'm finished.
Good job.
All right, sir. Finish. Can go ahead.
That's right, sir.
Okay. Let's go. So it says given given 7x squared y cubed plus 4xy minus 8x equals 0. We need to evaluate dy by dx at the point 2, -1. We're going to ignore the 2, -1 for now, and just focus on the implicit function, and we're going to differentiate. So 7x squared y cubed is a product. So I'm going to have the first, which is 7x squared times the differentiation of the second, 3y squared dy by dx, plus the second, which is y cubed, times the differentiation of the first, which is going to be 14x. That's done. I'm moving to the second term, which is also a product. So it's the first times the differentiation of the second. The second is y. When I differentiate y, I get 1, but I also get dy by dx. Plus the second, which is y, times the differentiation of the first, which is 4. Minus the differential of 8x, which is simply 8, equals 0. I'm going to be grouping my terms. I'm going to have, nope, let me fix up that first before I group. So I'm going to have 7 3 is 21. So this is going to be 21x squared y squared dy by dx. I'm not seeing Dijane. If she doesn't come to class today, it would mean that she has not been to class for a week. Anybody has any information about her?
No, sir.
Okay. And then this is going to become now plus 14x y cubed plus 4x dy by dx plus 4y minus 8 equals 0. Going to be grouping now. I'm putting all my dy by dx's together. 21x squared y squared dy by dx plus 4x dy by dx plus 14x y cubed plus 4y minus 8 equals 0. Are you agreeing with me so far?
Yes, sir.
Good job. I'm now going to be factoring my dy by dx, and I'm going to be left with 21x squared y squared plus 4x plus 14xy cubed plus 4y minus 8 equals 0. I'm going to be subtracting those terms that are no longer needed. And before I do anything else, now look at what I'm doing. As we get a little bit more mature in the implicit differentiation, I expect you to I expect you to I expect you to follow the steps that I'm taking. Okay, good job. So I'm going to be having plus 4x will equal to what I'm doing. 8 minus 4y minus 14x cubed. You agree with that?
Yes, sir.
A plus B plus C is the same thing as C plus B plus A. Addition is commutative. Okay. And then I'm going to divide both sides by 21x squared y squared plus 4x. 21x squared y squared plus 4x. That cancels that, leaving me now with dy by dx to be equal to 8 minus 4y minus 14x y cubed all over 21 x squared y squared plus 4x. So this is my differential. That's the first part of it. Are we okay with that?
Yes,
Yes,
sir.
sir.
Good
Yes,
Yes,
sir.
job.
sir.
Good job. Now at the point 2 comma negative 1, the value of x is
2.
good job, and the value of y is going to be negative 1. It's going to be 8 minus 4 times negative 1 minus 14 times 2 times negative 1 cube all over 21 2 squared times negative 1 square. If only the pen would write. Negative 1 square. Come on, pen. Plus 4 times 2. That gives 8 plus 4. Negative 1 cube is a negative 1. Negative 1 times 2 is a negative 2. Negative 2 times negative 14 is positive 28. All over. 2 2's 4. 4 times 21 is 84. Oh, times negative 1 squares is negative 1, so it's still 84. And 4 times 2 is 8. That's plus 8. So I'm going to be left with 28 plus 4, that's 32. 32 plus 8, that's 40. Come on. Over 84 plus 8, that's 92. So I have 40 over 92. Yes, it can be broken down into simplifying will give me 10 over 4 twos 8 and 1 9. 10 over 23?
Yes, sir. Or 0.4.
Hmm. That will yield about 10, 11 marks on an exam. About 10, 11 marks on an exam. Is there a student in the class that is still not following what is happening here? Moving on from implicit differentiation today into first principles briefly,
Sorry.
and then go ahead, please.
Since I did not get to attempt the question, you can give our next one so I can feel more comfortable.
Oh, absolutely. What I just want to get from you now is
So far, I understand the concept. I just feel like I need to do it to make sure that I'm understanding.
Okay, good job. Anybody else?
Sir, if you have a decimal, point, so 0.43 for the answer.
Yeah. I'm not a lover of decimals because really and truly you are dropping off some of your answers. If you follow what I'm saying. Because you're rounding off and you're not getting a exact answer. So really, I'm not a lover of decimals. So you'll see when I do my questions, I'll do my questions in a rational form. And a rational form is really a fraction. Right?
One more thing.
Go ahead.
So the reason you had flipped it from, what was it? From 14xy cubed plus 4y minus 8. So just flip that, right? If you never flip it, it would get a negative number, right? Or a negative fraction.
I don't understand what you mean by flip. What do you mean by flip?
All
I
right,
didn't
it's reciprocate, really.
I
That's what
didn't
I'm trying to
reciprocate.
say.
I didn't reciprocate anything, Papa.
Oh,
Alex, this is you?
yeah.
What happened to you? You weren't asking this question last class.
No, all right.
Where are you? Are you right here moving into here?
I'm at the second bit, yeah?
Uh,
Yeah.
So you're right here moving here.
Yes, yes, yes.
Remember, we're not carrying anything over an equal sign because we know them things are impossible. Right? So
Yeah.
what we're doing, we're using the additive inverse. So in order for me to get rid of 14xy cubed from one side to the next, I need to subtract it from both sides. So that's why it now becomes negative 14xy cubed right here. I have a positive 4y here. In order to get rid of it, I'll have to subtract it. That's why I did it. What I'm finding are the additive inverses of those three terms to move them from one side to the other. Yes? No?
All right, I understand. I understand.
I'm not convinced.
No, that was just,
No, I'm not
that was,
convinced. Are you sure you're understanding now?
yeah, I understand what you're saying. You're just finding the additive inverse of it.
Right. Right. Any other comments so far? I'm very aware that some of you in the class now have a clue what searches do a while ago. All you see on the board is XY, and numbers. It don't mean a thing to you. But you refuse to say, sir, I need a bit more clarification. So because JJ asked to give another example just to see that we are fully where we ought to be, I'm going to generate yet another question for you. For those of you who did the question and got it right, though, congratulations. You are proving to the class that this thing can be done and can be done online, that you guys are understanding. And I really hope it will motivate those of you who are lagging behind. All right, let's go to question number 2. What shall I give? Hmm.
Sir, you can give another one with the power, with y having a power greater than 2
Okay.
or 1 or whatever. Yeah, yeah.
Okay. No problem.
Because I noticed that difference there. Mhm.
All right. So on the mark, gets it go. Are we finished, guys?
Almost, sir.
Okay.
Sir, can you let you know?
I'm waiting on somebody to tell me that they're ready. I'm sitting here waiting.
Yes, sir. Ready for let you know.
All right then. Okay, so let's go. All right. By the way, before I do that though, how many of you have completed the question? Is there anyone still working?
Sir, I
Yes,
started
sir.
over because it just never add up for me, so I might start over. But
Yeah.
you
So
can go ahead.
right. You saw what I did there with the power rule, right?
Yeah.
But I'm wondering, should I
Sorry, question.
go ahead?
You combine the power rule and the chain rule.
Yeah, combine everything there, yeah. But
Yeah.
I'm gonna show you how to work this one. Interesting though, the power rule here. Did you differentiate everything like you're doing an explicit differentiation? How did you do this, Art?
Sir,
Never mind.
so for mine, what I did is
Mm-hmm.
it's exactly like how we do it. So it would be 2, and then what's inside the bracket remains, and then multiplied by what's the differentiation of what is inside the bracket, which is the what's that rule? The product rule.
Mm-hmm.
Yes, that's what I did, sir.
All right, I'm going to show you an easier way. Yes, it's still the power rule, but it's because we're doing an implicit differentiation. I'm going to show you a method that makes it so much easier. Maybe this is why you had to
Maybe.
start over.
Right, yes,
Yeah.
sir.
So let's go. Even though it's a power
Oh,
rule, still. But let's go. Let us see how far we got to. We can get up to it. All right. So 5x to the fourth by to the fifth. Now remember, that's a product. So it's going to be the first
Times
times the differentiation of the
differentiation.
second, which is 5y to the
5y
fourth.
by
Oh,
dx,
very
dy
good.
by dx.
dy by dx. That's the first plus the differential of the second. Sorry, plus the second times the differentiation of the first, which is
20x
20x cubed.
cube.
good job. Finish that up. Now watch what I'm going to do with this one here now. This one, let me do like a side work, and I'm going to put the side work in a different color.
Oh, side dx.
Yeah, whatever. Side work is going to be x cubed y squared all squared is exactly the same as.
Sir, Siobhan has his hand raised.
Sorry, somebody had a hand raised. Who?
Siobhan.
Chevy, go
Oh,
ahead.
well, I guess it was a
Oh,
Okay, yeah.
sir, I was just saying, I just solve it the same way how, you do the pour rule, then the differential what's inside,
Yeah,
which
man,
would be
and
the
that's fine.
product.
And that's fine. That's fine. But that is going to be a little bit more technical than the shortcut method I'm showing you right here. So you keep what it is that you have. Moya did that way also. Keep what you have. I'm going to do it this way. Are you there? 1 to 9, Joe?
But, sir, can you show us the two working?
I could actually. I could.
Show
That's what
us
I'm
the
going to show.
two-way, please,
I
because
can. I can. But I'm going to show you the ease of the two first. So my x cubed y squared is the same as x to the 6 y to the 4th. Can you agree with that?
yes,
Yes,
sir.
sir.
Right. So let me just give you the recall. The law. The recall is a to the m. Recall. A to the m raised to the nth power is equal to a to the mn. So my x cubed raised to the second power is going to be x to the 6th. You're multiplying. And my y squared raised to the second power is y to the 4th. So if I want, I can call this minus, and I'm going to put this in a different color. So it's minus, and I'm doing it like the last time. Remember the last time I left the minus sign out in parentheses and then distribute the
Yes,
minus sign.
sir.
Right. So it's going to be now the first x to the 6th times the differentiation of the second. Times the differentiation of the second is going to be 4y to the third dy by dx. Agreed?
Yes,
Agree,
sir.
agree.
Yes, sir.
Plus the second, which is y to the fourth, times the differentiation of the first, which is going to be 6x to the fifth. And then I'm differentiating now 3xy. So again, that's going to be a product.
Sir, you can, if you want to move this over, I can, well, your tablet won't be able to. I don't know if you'll
Well,
be
well,
able
well,
to.
well, 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 let me just give you access, because that's why I said well a while ago, because I'm saying to myself, how do I do it? All right, so you don't have access. Can you just block
Yes,
and shift and
sir.
carry, please? Thanks.
Sorry, sir. This okay. I'll leave off the stroke.
Yeah.
No, that's fine. I can put back the stroke where it is. Oh, right, that's good. That's good.
Okay.
Thanks. So the stroke came from the recall.
You can stop the
Yeah, I will.
playback.
Yeah, thanks. I appreciate it. Where was I now? Right, so I'm differentiating now. 3xy. Again, that's a product. So it's going to be the first times the differentiation of the second, which is 1, dy by dx, plus the second, which is y, times the differentiation of the first, 3x, is going to be 3. And that is equal to the differential of a constant, is going to be equal to 0. So that's there. And then the differentiation ends there. All I'm going to do now is to fix up.
Sir,
5 times, go ahead.
I definitely went wrong, but I definitely see where I went wrong.
Great. I'm happy. Happy that you see where you went wrong. Nigel, saying something?
Yes, sir. The last part after the color code the way you do,
Uh-huh.
I have everything we have there in a black the same way except that green piece that new to myself.
Right, no problem.
Yeah.
And the green piece, and I believe that's where Moya had to redo her stuff. Because what I think all of you did was to apply the power rule there. All right, let me just say something to you. I'm hoping to start differentiation. I'm hoping to start integration tonight. And one of the things you'll recognize, differentiation is the same thing you're doing over and over and over and over and over again, except that you have some little nuances, like we talk about the differential of the exponential function is the exponential function itself times the differential of the power. We talk about the logarithmic function, it's going to be 1 over the function times the differential of the function. So it's just the different nuances, but the differentiation remains constant. Integration, on the other hand, you have a gazillion and one rules. So whereas they can give you anything for differentiation, for the integration, I will have to, it is going to be limited to what is being asked of you. Now, sometimes, this is the point I'm making, sometimes they ask you to integrate a function, but the function in and of itself is not integratable, or it makes it so much difficult to integrate. So what you'll have to do is to make a substitution. So you make the substitution, and when you make that substitution, you'll have to differentiate that substitution. So while you're doing the integration, you have to do some, while you're doing the integration, you will have to do some differentiation alongside with it. So I'm saying to you, you have to look at the question, not because you know that it is a power, you mean that it can be worked as a power in and of itself. So that's a level of flexibility, maturity that I'm going to develop in you. To be ready for the exam. So we will get there when I look at the other method, but for sure, this one is going to be much easier for us to do. Let us fix up.
Sir,
Go ahead, please.
on that note, remember you were supposed to add the logarithm,
The
whatever
logarithmic
that,
sub. I remember I
and
saw it and sent it out. For the rules you're talking about,
right,
don't?
yes.
Yeah, man. I saw them today when I was downloading the oh goodness, the coursework pieces for the business calculus students. I saw it, but I did not type it just yet. But what I have already typed are the rules for you for the integration that I'm going to share in a few. So I need to
Okay.
include was it the exponential and the logarithmic rules, right?
Yes, sir.
Right. I have not done those yet, but I will share the integration one with you. Yeah. All right. So let me just be honest as how I know how to be. So the system, I use a software to type my stuff. The tablet does not give me that level of flexibility to type the well, yeah, okay, yeah, it doesn't give me the flexibility. The software is not on the tablet. So I do have a computer beside me, but it is really a computer, but it's really a laptop. So it has to be plugged into work. And I took it out without the charger today, just to be able to download, to transfer the information from the computer to the tablet, so I could start marking those. So where I do have a laptop with me that I can share the document with you, I'm sure by the time I start downloading the stuff to share it with you, it's going to die on me. So that's why I can't send it off to you now. But the other one
Okay,
though, I have, yeah man. All right, let's go. Five fives,
25.
25. So this is going to be 25 x to the fourth, y to the fourth, dy by dx. Chevy, you all right? Plus 20x cube. Chevy, did I answer your question? Did I answer his question? He said that his hand was up. All right, he
so
not hear
he
me.
just made a comment, sir, saying that he did it the same way
Oh, okay,
where
yeah. I was just wondering, right? So look at what I'm gonna do now. I'm gonna do two in one. I have two terms. This is gonna be four. So this is gonna be negative 4x to the 6y cube dy by dx. Check and see if I'm correct, please. 4, 6x cube, yeah. Minus again 6x to the fifth y to the fourth plus 3x dy by dx plus 3y equals 0. I'm going to group. And then I'm going to have 25 x to the fourth y to the fourth dy by dx minus 4x to the sixth y to the third dy by dx plus 3x dy by dx plus 20x cube y to the fifth minus 6x to the fifth y to the fourth plus 3y equals 0. Then I'm factoring out my dy by dx to be left with 25 x to the fourth y to the fourth minus 4x to the sixth y cube plus 3x, and then that is going to be plus 20 x cubed. You recognize that the differentiation finished here, so it's just algebra that I'm doing working with now. Y to the fourth plus 3y equals 0. Just be careful that when you're doing this to reduce the functions, that you don't make any errors in doing so. Dy by dx is going to be equals to 25 x to the fourth y to the fourth minus 4. Come on. Here you 4x to the sixth y cubed plus 3x, and then I'm going to say equal. Look at what I'm doing. positive 6x to the fifth, y to the fourth. Can you agree with that? Hello, somebody?
It is.
Yes, sir. See it.
Okay. All right. So I don't want to put a negative sign in front of my equal sign because it may very well look like an extended equal sign. And while working with it, you may forget that it's a negative sign. So as best as possible, if I can put the negative sign in betwixt the stuff, I am going to be doing that. So it's going to be positive 6x to the fifth, y to the fourth, minus 20x cubed y to the fifth, minus 3y equals 0. Then I'm going to divide both sides by 25 x to the fourth, y to the fourth, minus 4x to the sixth, y to the third, plus 3x all over the same thing, 25 x to the fourth, y to the fourth, minus 4x to the sixth, y cube, plus 3x. This cancels that. Therefore, my dy by dx is simply 6x to the fifth, y to the fourth, minus 20x to the third, y to the fifth, minus 3y all over 25x to the fourth, y to the fourth, minus 4x to the sixth, y cube, plus 3x. Difficult?
Apart from that first bit, they have the x
The one in
cubed y
the one the
yeah.
one the one in the green.
Yeah. It's
Okay,
pretty
got
simple
you.
after that.
All right.
How much math this work?
To be honest with you, a question like this, because this is long, a question like this would have to be about a 12 marker to 15 marker, about a 15 marker.
How much a normal question would have
A normal question like this is about 10 marks, anywhere between 7 and 10 marks. Normally about 10 marks. Most times it's 9 marks. You know, yeah, they're about. All right, let me do the second part. I'm just seeing that it's negative 1, comma 0. So when x is equal to negative 1, y is equal to 0. Also, yeah. So therefore, dy by dx is equals to 6 times negative 1 to the fifth times 0 to the fourth minus 20 times negative 1 to the third times 0 to the fifth minus 3 times 0 to the plus 3 times 0 all over 25 times negative 1 to the fourth times 0 to the fourth minus 4 times 0, no sir, times negative 1 times negative 1 to the sixth, come on, times 0 to the third plus 3 times negative 1. Dy by dx is going to be equals to 6 times, four, Rockstone. What is this answer? Here will be an answer. Can you
Negative 6.
No, if I clap you see JJ, aren't you see the zeros there?
Oh, sir, I thought you meant
Is that
we're going to
indeterminate
break it down.
undefined?
No, it's not undefined. Come again.
So, sir, that section right there is 0.
What is 0?
Top
As in, wait,
top 5.
Don't tell me
Numerator.
the top part.
Numerator.
oh, top
0
one.
over negative 3.
I'm saying I don't want to hear the top part. Thank you,
Oh,
Crosswell. I want to hear numerator.
Numerator, sorry.
So the
Numerator.
numerator. And what's the denominator?
negative
Negative
3.
3.
Very good. Right. So
Sir, you're not hear me. I literally just said it.
I didn't hear you, Mimi. 0 over negative 3 is what?
0. Alright, is it?
If I still on this, I'm going to stop it in a second.
No, sir. If you stop it right there, you lose a mark. 0 over negative 3 equals
0.
0. So therefore, dy by dx is going to be equal to 0. Remember, I heard somebody said earlier undefined. Undefined only occurs when the 0 exists in the denominator.
No, I never say undefined, sir. I say indeterminate.
That even makes it wronger. No. Tell me why it's wronger, class. Because indeterminate is what?
Is the same as
Limit.
undefined.
No.
Is it
Moyo.
limits?
Sir, all right, now shut up. I remember.
So isn't it limits?
No. When you're speaking about something that is indeterminate, what form do you have?
Oh,
See,
sir, you use the
The
infinite,
denominator,
infinity something. I
that's when
remember.
the
okay.
answer
So
equals
hold
Oh
on,
my
guys.
gosh.
Hold on. I can't believe it's that's exactly what I'm saying, Moya. Hear me out. If you have a rational function is a fraction in numerator and a denominator. And if you have a rational function, what are the different forms of indetermination? I give it 3 indetermination forms. What are they?
Sir, 0/0.
Thank you.
Oh
So,
yeah,
so,
that's
so,
it.
so
And
ra-
infinity over infinity, negative
uh,
infinity over
very
negative.
good, very good.
Yeah.
So if Nigel wanted to say indeterminate and he's seen only 1 0, it couldn't be indeterminate because the denominator is not another 0. You follow me?
it will
So
be
it has to be
undefined.
0.
But
No, Nigel,
if
it's undefined when the 0 is in the denominator.
the
Guys, you're not
denominator,
forgetting.
yeah,
Right. So when the 0 is in the numerator, the result is 0. Because you can have a 0 existing in the numerator. When the 0 is existing in the denominator, it is undefined. When you have 0/0, please remember 0/0 is not 0. 0/0 is indeterminate when you find the limits, because it is saying to you that there is something in the limit preventing the true limit from coming out. So you need to do one of 3 things: a factorization, a rationalization, or a simplification. When you're not studying.
a joke can make, sir.
All right then. No, make sure it's a joke me make, because
Go on with yourself, sir.
Ah,
all right. That's all I want to know, is that I'm
wow.
joking. All right. Okay, JJ, you were asking for another. Oh, sorry. How you feel, by the way, JJ? You feel better now with this one?
Yes, sir. Funny enough, even with
Mm-hmm.
my wrong answer before, I still got 0/-3 for the coordinates part.
Okay. All right. I don't know how that worked out, but fine. Fine. All right. Let me tell you what I prefer not to do. I hear Maya, I hear Chevy, and I hear
Sir,
Nigel asking.
hold on a minute, whenever they talk about by some miraculous conception, I arrive at the answer. Um, Looking at the hieroglyphics that you wrote, I'm seeing different numbers compared to mine.
Mm-hmm.
Um, I'm still at the right some way, somehow, but we can continue.
Yeah, but I'm almost sure though that the value for dy by dx is not the same that I have. And more and JJ, tell me, the value for dy by dx, the dy by dx, the function, it's not the same thing that I have on screen now, right?
No, sir.
Okay,
Sir,
so go ahead.
mm. Sir, so you're going to do it the other way, right?
Um, to be honest with you,
Or
I
you don't
could,
want
I
to?
don't. I'm going to tell you why I don't want to, because some student is when they look at it and is when they get confused. Because the
Sir, at
other way,
least if you can do it afterwards, I
and so
would
that, so
say,
you know
because
what I would prefer? I would prefer doing it and then sending it to you.
okay. Please don't
Because
forget in a sir,
no man,
because
just
then
remind
I'm
me.
going to be lost.
No man, just remind me. But what I want you to do, I want you to do the easier of the 2 ways. Because if I do it now,
Definitely.
some student is going to get confused and I don't want to throw off anybody. So I can do it, and then those who want to see it can look at it with one eye. If it don't look like what they want to look, they just shut 2 eyes and then just straight away. But I can do it. I will do it outside of class, because really and truly, I did it there just to trick you. But yes, it is a power, but we're going to be working the power another way by doing the expansion of it.
So it's
Okay.
basically either either situation.
Yes, either, but the either is better than the either. Put it this way. Sometimes I get questions And the questions will say, hence or otherwise. Do not in Jesus' name do the otherwise. Use the hence. And let me explain what hence mean. So Moya saying something to me, and then I say hence. Hence means no, that she will have to follow from the last statement that she made to continue the conversation, the new conversation, using the last information that was made. Now, if she uses it otherwise, it means that she has to use a whole totally different method in order to come up with that answer. So when you're doing CXCs, they would normally do that too. Hence or otherwise. Determine the value of whatever, whatever, whatever. If you use it otherwise, dog nyamisoppo. Don't use otherwise. Always try to use a hence. So this is like a hence or otherwise, no guys. That with this we call it the power rule for this one, for the explicit, for the implicit. The explicit for the power rule is easier than the implicit. Why? Because for the implicit, you just have X and Y that you're using the laws of indices to
Hold
expand.
on, sir. Hold on. You say the explicit is easier than the implicit.
Mm-mm. It's supposed to be the other way around. The implicit
Oh,
is
because that's what
easier.
you said, sir.
Right. The implicit is easier than the explicit to work in this thing. You follow me? And you mix and you agree with this, right?
Yes, I now
Because
agree.
because the explicit will be something like 2x plus 5 raised to the fifth power. And you have to go do that expansion all the way up to the fifth power, and that is going to be a whole lot more. All right? Okay. That
Hold
is
on, sir.
it.
Before
Go
we
ahead.
move on, I'll just review about the question. Where you have with the original line with the function where in the brackets x cube and y squared, you just multiply the powers.
Yes, sir. Yes, sir. So the side work here, just applying the law of indices, a to the m raised to the nth power is equal to a to the m times n.
Okay,
Yeah, man.
no problem.
All right. I want to pivot a little, and I want to I think based on those of you who Mario, you know that I'm not really hearing from you in class though. Talk to me, Mario. Are you understanding what I'm doing, Mario? You really don't talk to me in class.
Sir, a little bit, sir, but may I follow along, sir?
No, but you can't be understanding a little bit and following. That is like saying repeat again or the rain is falling. That statement don't make no sense to me. If you're following, if you're understanding a little bit and following, all right, never mind. Nicole, I'm gonna call on you one more time. Last time I said that you couldn't talk, and I did. Are you following? I was trying to have a conversation we did in last class. Are you understanding? Because you don't talk also in class, you know.
Yes, sir, I understand.
Okay, you're on mute and talking to me tonight. All right, good. Rolando, how
Sir,
you stay?
sir, and sometimes I understand, but you're not hearing me.
Oh, really? Oh
Yes,
no.
sir.
Well,
Even since that when I was saying 0, -3, you weren't hearing.
oh, so you must tell me, say, sir, this is Nicole, and because I want to hear you. All right, I apologize.
Sir, I'm not a loudspeaker.
I'm gonna put on my glasses next time so I can hear you well. Um,
Okay.
good. Rolando, how you stay?
Yes, sir, I'm here, sir.
No, me no want you there. Me know you there. Come and see you in the class. Me want to know how you stay.
I'm doing my best to follow along, sir. Matt,
All
yeah,
right.
I'm doing my best.
All right. You're like somebody who is related to me. When I ask a question, everything is good and fine. Are you understanding, Rolando?
Yes, sir.
Okay. Okay. All right. All right. The rest of you talk to me in class and know that you are. If you have an issue, you talk to me. Woof, puff. I noticed the numbers kind of dwindling down. Didn't we have a snipes in the class? Is this class or the other class I have? But
Definitely this class.
we had a snipes in this class, don't? And I call him, where's the snipes, don't?
Sir Errol has dropped out.
Yes, sir.
Where is he? I've not seen him for quite a while.
So he dropped out, sir.
Oh,
He
he dropped.
lives St.
Oh,
Elizabeth, I believe, thereabout.
oh,
Yeah.
he's in St. Elizabeth?
Yes, sir.
Yes, sir.
Oh, Jesus.
I mean, sir, the context of dropped out meaning that he's not continuing the course, not that he, if that's what
Oh,
the,
no. I didn't get, no, not passed on. No, not
oh,
passed on. But I'm
please,
just saying,
'cause-
but somebody said
Mhm.
St. Elizabeth, but I only say, oh no, because clearly he was really disenfranchised if he were
Yes,
living in St.
sir.
Elizabeth.
Yes,
Oh,
sir.
crap. I didn't
I
know
have
that.
siblings here that still are picking the pieces from that stuff. Yeah.
Oh, yeah, man. And 5 years later, they're still picking it up. Trust me. Oh
My
no,
brother
sorry.
house, my brother house get ripped out at foundation.
Oh no, that's serious. All right. All right. Is anybody in contact with Snipes?
Yes,
Errol?
sir.
Snipes.
I do.
So is it that you remember the exams are in January now? Is it that
Sir,
we
it's
can
among other things, but I can't say it
you can't say,
here.
all right, do me
So,
a favor, just
mhm.
ask him, share my email and just ask him to talk to me now, please. I don't want
Yes,
him to drop out.
sir.
Please and
Okay.
thanks. Is there anybody else in the class that is, I know you said Colin um has dropped out himself. I mean, also from the course,
Yeah, just for this sport,
just for this course.
because him same can manage.
All right, I need to have dialogue with him because he was supposed to all look on the computer for me. No, him drop out. Him go down and want look on the computer for me. The one that crashed. All right.
Oh,
Is there anybody else in the class? I mean, he's not like that. I'm just joking. I've taught him before, so I know he's a nice guy. Is there anybody else in the class that you're not seeing again that I should know that have dropped out of the course? Yeah, no.
Sir, probably not dropped out, but I think they're having difficulties. Onika Morgan and Kimberly Crossley.
But Kimberly was here last class.
Okay. I think Aquila Thomas as well. I'm not really
Okay.
seeing them much online.
Yeah, and they don't come to the other class either, or classes. We're just concerned. The truth is, I don't want anybody to be left behind. And if they're having a difficulty, if the difficulty is just getting connected to the class, I will try as best as possible to reach them otherwise, if you see what I'm saying. I don't want it to be because they don't have internet access, them say them can't bother and them going drop out of the course. So please just pass it on to them for me, please. If the situation is dire, other than, beyond my control, so to speak, then I can understand. But if it is within my ambit, sir, I can't continue because though I'm willing, I don't have electricity, neither do I have internet access. That's no excuse for you to drop out. Talk to me. Me can find a way for reach you so we can do some stuff. All right? Um, yeah, but I don't want anybody at all to be left behind. And also I hold you guys, funny enough, I was having a conversation with Mrs. Campbell today. We were in a meeting early and we were early for the meeting and I just had a side talk with her and I told her, was giving her an update and was just saying to her that, this is a really mature group and, you know, very nice class working with. And we were just talking about some other students and, ultimately I had a calculus group that's, you guys will really have to top their performance. They were a set of workers. From that group, I had a valedictorian coming from that calculus class, and the boy rubbed me out, at the graduation. As for calculus, I just sit down on him and just look on him and say, yo, it's all right. The vote of thanks person came from that same calculus class. Um, and yeah, man, that was a very good group. So I'm going to see this group to see how far this group will go. You know, yeah, so I was just talking to her and let her know. But I really want to meet those of you who are having, those of the students in the class are having a difficulty. Don't drop out because you don't have no internet or you know the electricity. We can find ways of meeting for us to get the stuff done up. All right. I want to pause here. I'm not going to give any more questions on what do you call this? Implicit differentiation. I think you get the gist of it. You have the gist of it. What I want to do is you know what? What time is it?
Oh, sir.
Go ahead, my love.
Remember you asked to find some
Past papers?
yeah. I can't access, well, I did find some, but the file format is bib text. I don't know if anyone know how to what's that?
What's the file format?
Convert that. It's bib text. Well, the file formats they offer, they are very alien like at the first time I see them, so I don't know. It's bib text. That's it. It's in the chat, so anyone know how to convert that?
I think somebody just called him on you.
Yes, the Lord people them in our household.
Oh, sorry, Jesus. It sounded like you saw somebody in the class. Oh my goodness.
I can send it. I'll try and convert it.
Okay, okay, I'll send it.
It sounded like all right. I have a challenge. Oh, hold on, let me see. Okay, is that right? It's not so much of a challenge again. All right, it came out all right. It came out all right. No, man, it's supposed to have. Ah. All right, I have the rules. I'm actually looking at it, students, but I'm actually looking at the rules, but I did say to you that I use a software to type my stuff, but I didn't convert it to a PDF. Okay, hold on. All right, okay. I found another copy. All right, you know what I'm going to do? There is, remind me that I have Zoom. Are you able to download that document if I share it like that? Or is it on the screen?
Yes, sir.
No. Yes, Alessandro.
But are you able to download it like this? No?
Sir, we can just screenshot it, sir.
Okay. All right, go ahead and screenshot it then. There are two. All right, let me see if I can. Let me see if I can do it another way too. This is save to files. This is oh yeah, but I don't have it there too. Online teaching, interesting business calculus, rules, and then go here. And no. Oh yeah, let's stop share. Students,
Yes, sir.
Yes, sir.
forgive me. I Today's the 21st.
Yes,
Yeah.
sir.
Okay, so I'm able to find back this whiteboard, but I came off. Let me see if I can share that document with you. Um,
I'm going to save this just in case.
Please and thanks, cause
Mm.
I just came off a while ago unexpectedly. I thought I was gonna lose everything. Business calculus. What am I looking for now? Rules for integration. Ma, you don't save it yet. Hey, something, don't play with me.
Remember to turn off your whiteboard, lock them, whiteboard.
Yeah, thanks. Rules for integration, but isn't there an eighth page? I mean, an eighth rule. Hold on, let me just see. All right. What am I looking for? Lord. Give me half a second, please. All right. All right, so I'm in a little problem here. Because I am here teaching.
What's
And
the issue, sir?
I am here teaching and not recognizing that I only have 12%.
Wow.
Yeah. I'm having 12%, but let me see now. I have my stuff here doesn't to transfer the charging. So disconnect this one. And do I do this? Okay. All right. So yes, I'm going to teach you some integration tonight. And I was saying to you, please remind me that I have first principles to do with it. I did skip it out because I was doing some stuff with the business calculus, as I told you. First principles is not bad, but I really don't. It's now 7 o'clock and we have just an hour left, and I really want to do some integration with you for that hour. I mean, I can start integration and get a good way into the 1 hour of integration. Differentiation, we're good with that. Let me do that one time with you. So forgive me. I'm most moving to integration. Let me just close this document here so I can hold on. Let me just close here. All right, so that is close. I'll put up like that so that I can find it when I want it. And I plug this one in and hopefully I can start getting some charge. Praise the Lord. Okay. All right, are you with me now? Can you hear me again now?
Yes, sir.
Okay, great.
Yes, sir. Yeah.
All right, but so I'm getting a little juice out of this charging port. All right, so I'm excited because we are into. Let me go back to this. Let me go back to my shirt. Right, I'm excited because we're moving into some big school mathematics now. We're into some integration. Wow, this part of it is nice, and I really want you to draw close. Draw close as I'm introducing this topic for you with you. Let me just start off and just tell you how important this is. I did mention it at some point in time. Hurricane Melissa come. Hurricane Melissa devastated the whole of the western part of the island. But guess what now? Moya's great grandfather left her a piece of land, a plot of land in St. Elizabeth. But that plot of land is on a slope. Moya says, you know what? I want to be a part of this smart city that is being built. So I'm going to start building my house. And I'm going to be building my house. Trust me. And incidentally, if you know the family members, guys, real talk. If you don't have family members who have lands, talk to them and say, yo, what go on? Even half acre. And you get something either you're going to build or plant. Right? It's very important. Trust me, it's so expensive to purchase. But anyhow, if you don't have it otherwise, this is the only thing you can do. Hey, maybe it's just wisdom that that it comes with. So you have this plot of land. But Moya's plot of land now, she looks at it and she says, but I can't do much with this. And it is just a little small because her siblings got a little piece or something and it's sharp and everybody want them plot of land. And Moya says, but I did calculus. And I know I can increase my square footage by going up. What Moya did was to find the area under the curve. So she would have integrated and found how far down she can go. And Moya decided, yeah, I can build a whole unit in the basement. I can have a basement garage. The foundation is going to be even more sturdy because I'm going all the way down. And then what is going to happen is that I'm going to go 2 stories up. So not only that she has a basement apartment, she can also get 2 stories up. So the square footage that she has is now increased. And incidentally, that's what they do. When you're building, you can increase your square footage by just building 1 story on top of the other story up on the other story. So now, and then she's doing all of that. She wants a swimming pool, but she's doing all of that, and then she say, you know what, I'm gonna have that swimming pool. I'm going to build that swimming pool, but she don't have any more space in the yard, so she decides, say, yo, rooftop swimming pool. And she seal that place good and proper and build a swimming pool up top of the roof, right? And it works well. Matter of fact, where I'm at now, I can't see it from where I'm at. But there are two hotels near to where I'm at just now that have their swimming pools on top of their roofs. That's the way to go. You're maximizing your space. This is what integration is. All of what I just explained to you there is integration. Them are maximize and utilize every bit of space that them have. Watch me. So integration is going to be taught just by giving examples. And we're working the examples. Right? So if I say to you, oh, and this here, oh no, I don't like when you decide, so you're going to get dark on me, you know. What that's too, is that too bright or that's fine? Talk to me now. Too bright or fine?
Good, sir.
Okay. So this elongated S is not the S well look so you know. It's an elongated S. That's the sign of integration. The elongated S is a sign of integration. Right? So that's what those signs are. It's not an S, it's it's the elongated looking sort of stuff, right? That's a sign of integration. No. So if I have, matter of fact, I don't even have to write it. There it is. Let me just highlight it. I forgot that I gave you the stuff. You have to see with me. Highlight, color. Let me do this. That's the rule I'm talking about. That's the rule I'm talking about. That's the rule. So the rule, the elongated S to the N. Nope, that's not what I want, Mr. Shand. No, not at all. X to the N, dx is going to be add 1 to the power, divide by the new power, plus C. And that C is a consta, constant of integration. So when I'm integrating x to the n, I'm integrating a function in x, dx. What I'm going to be doing is just adding 1 to the function, to the power, sorry, and divide by the new power, plus C. And the C is my constants of integration. Now, you have a constants of integration when you have an indefinite integral. When you have an indefinite integral, you're going to always have, if you look at that, you'll see the plus C, plus C, plus C, plus C, plus C, plus C, plus No. Go ahead.
Can you go over how we know when the integral is indefinite?
Okay, that's what I'm going to show you now. So it's indefinite when you don't have an upper limit. Okay, so this is what an indefinite integral looks like. Versus a definite integral. A definite integral is when I have an upper limit and a lower limit. No, and there's no plus c. So the definite integral has an upper limit it has an upper limit and a lower limit. The indefinite integral has no limits.
Sir,
go ahead.
Just to clarify, we're looking at, so out of all of these rules, we're looking at rule 3, right?
Right. So rule 3 is the rule to look at just now, right? We're going to look at all the other rules, but rule 3 is what we're looking at now, right?
All
So
right.
go ahead.
And the elongated S or
It's a sign of integration.
the sign of integration. Okay.
Another question?
Not at this time.
Okay, right. So rule 3 is what we're focusing on now, and then now we're going to look at the other rules in short order, right? So once it is that you're integrating, the sign for integration is this elongated S, and it will end with like a dx or a dy or a dq or a dp, and the dx in this case here, x to the n dx, that dx is telling me that my function is in x and I'm integrating with respect to x. Had it been dr, it means that I'm integrating with respect to r. That means my function is supposed to be in r. All right, but you can see that the function is in x because I have x to the n dx. I am integrating with respect to x. All right, now once I'm integrating either a definite or an indefinite integral, I am adding 1 to the power and dividing by the new power. Once I'm integrating, it no matter if I'm integrating a definite integral or an indefinite integral, the rule is to add 1 to the power, and then I'm going to divide by the new power. So it's going to be x to the n is what I'm integrating. So it now becomes x to the n plus 1, and then I'm going to divide by n plus 1 plus c. If it's an indefinite integral, you must have your constants of integration. Sir, what is this constants of integration? Okay, so if you don't have your known limits, you can't tell me fully what is going to be happening with the function. So if I know that, okay, in simple terms, Moya lives on Love Lane, but Love Lane is a long avenue from the top of one road to the bottom of another one, a long avenue with many houses on the left and the right hand side. Would it be easy for me to find Moya's house? Yes or no?
Well, you know the point where to begin, so you can just walk along.
But I don't know the house. So I know where to find, I know what vicinity you are in, but I can't find a house. No. If Moya says to me, I live at 10 Love Lane, I know exactly where to go.
I get it.
Right.
Yeah.
So I know Love Lane, but I don't know where on Love Lane. So that plus C is when they say, give me more information and I can tell you which of the houses. But when I have the limits now, I can say X, Y, Z. And incidentally, your houses are limits, you know. You know, if you think about it, you live at number 10, your neighbor up top is number 8, and the neighbor to the other side is number 12, because we use like an odd number, even number sort of situation. So you have 8, then 10, then 12. So when you look at the end of the beginning of one wall for you to the ending of another wall for you, those are your limits. It means, say, within that stretch, when the gardener man come for cut, the gardener man supposed to cut right at the stretch there, the limit of your house. So you can't cut from the gate to one side because the other side of the property now going to get cut. All right? So when I have a limit, I know exactly where it is that I'm going. I don't need a constance of integration because I have enough information to sort out. When it is that I have no limits, I don't know where I'm at, I am going to be dependent upon other things in order to get some further clarification. Watch me. That's it. Integration done. The introduction part, that is. Watch this. For example, oh, come on, pen, just behave yourself in the mind. Sure. You keep making me talking to myself in class like, come on. So, I'm integrating x squared plus 5x plus 6 dx. Do you understand that dx now? I am integrating with respect to x. Watch me. I'm adding 1 to the power and I'm dividing by the new power. Watch me clearly, closely. I'm adding 1 to the power. X to the third divided by 3 plus. What power is that x for the 5 is written to again?
1.
Good job. So this will become now 5x to the second power divided by 2. What x is that 6 written to again?
1.
1.
Do you see a 1 right there beside the x for the
I was
6?
gonna say nothing.
What x? What is the power that x is written to? You have to assume that there's an x, because you're integrating with respect to x. Thank you. 0. And 0 plus 1 is?
1.
So that's going to have x divided by 1, which is really, add 1 to the power divided by the new power.
So repeat what you said about the x value.
All right. So, and I'm going to repeat it. I'm just going to show you.
You can start over from the top one more time, please.
So what I'm saying to you is, if I gave you a function, x squared plus 5x plus 6 dx, and I'm asking you to integrate the function, you're going to be adding 1 to the power and divide by the new power. You're adding 1 to the power and you're dividing by the new power. So what I'm saying to you is, you are going to be adding 1 to 2. You're going to get 3. So this number becomes x cubed, but I'm dividing by the new power. So it's going to be x cubed over 3.
Yes,
I'm adding
sir.
1. Go ahead.
And for the 6, there is why you
No,
get.
man, hold on. I don't reach here yet. Hold on.
Okay.
So you know that this is when you're not seeing a power there, you can assume 1.
Yes, sir.
Good. So that is 5x to the first power. So you're adding 1 to the power. 1 plus 1 is 2. So that becomes 5x squared. But you're dividing by the new power. So it's going to be 5x squared over 2. Let us go to this 6 now, but I want you to look at this.
Sure.
Go ahead.
So because in this case x raised to the 0 will equal 0.
No.
Sorry. No. All right, let me start over. 6, the variable for 6 is implicitly x. So that's why you get back 6x right there.
Yeah, but you said something that I'll come to you, Papa. I'll come to you, Papa. What is this? What is this value equal to, Moya? X to the 0.
1.
Thank you. Okay, go ahead now with the question, sir.
Sir, I'm looking at this and just by reading what is on the paper, it says we're doing the inverse of differentiation.
Very good.
Right.
But you jump in the gun. Can I ask you to just hold that question for me? You see the mere fact that you say inverse of differentiation, I'm going somewhere with that inverse. But I have to do this part first to show you the inverse. So hold that question. I'll soon come to you. I promise. That's all right?
Come on, sir. Come on.
All right, cool. So look at what is happening here. So I could have written this as 6x to the 0 right here, so. But I don't have to because x to the 0 is equals to 1. Talk truth.
Yes, sir.
Good. So when you're not seeing, sir, how we know it says that x is supposed to put here is what I think you guys are asking. See it right here, so? Dx. And see it here, so? X right here, so, and x right here, so that means this function is also in x.
Mhm.
So we are just adding 1 to the power. So what it is, you're adding 1, 0 plus 1 is 1. So that's why it now becomes 6x. And then you have to include your constants of integration. And then, and a matter of fact, this is the answer. This is the answer. No. I think it was Alex who asked the question, but sir, I'm reading the paper and it says integration is a reverse process of
Sir, I never,
differentiation.
no. I never made that. No.
Say that again.
I never made that, sir. I think they should have.
I should be this so. One I wanna and talk fancy, but sir, I'm reading the paper and it says
Sir,
1 is the
so
inverse.
I was just picking up that
No man, that's
one.
fine, and I'm happy that you did it. I'm happy that you did it, right? It gives me excitement because right about now I'm excited. So let's go. But you're right. The one is the inverse of the other. I did say this to you some time ago in class. The inverse, opposite, same, interchangeably, synonymously used. The inverse of differentiation is integration, and the inverse of integration is differentiation, right? And integration, sometimes they call it the antiderivative, right? So if you, matter of fact, I'm going to just tell him, I'm going to show you and see what it says. It says the following rules for indefinite integrals are obtained by reversing the corresponding rules of differentiation. The accuracy is checked by taking the derivative of the antiderivative. Rockstone. The antiderivative is the integration. So if we have something that is integrated, all we have to do is to differentiate it to see if we're on the right track. Sir, what do you mean just differentiate it? All right, let's go. I'm going to check something here. I'm differentiating each of these terms to see what is going to happen. When I differentiate, x cubed to the third. No, no, I'm not going to do that. We know the rules of differentiation, we're going to do it. I'm differentiating x cubed to the third. Y is equals to x cubed over 3. We're doing the differentiation. dy by dx is equals to the denominator, 3, times the differentiation of the numerator. What's the differential of the numerator? Come, work with me.
3x squared.
3x squared minus the numerator, which is x cubed, times the differentiation of the denominator, which is
0.
0 over the denominator squares, which is 3 squares, don't?
Yes.
So dy by dx is going to be equal to 3 times 3 is 9x squared minus 0 over 9. Talk truth.
Yes, sir.
And then the 9's cancel, so all I'm left with is x squared.
Yes.
Was that where we started right up here? So x squared?
Yeah.
See it right here, sir? So we know that this is the differential of that. Because we get that there. Let us try this piece here now. 5x squared over 2. And I'm not going to do this in the exam. I'm only doing this because I want to prove a point to you. Y is equal to 5x squared over 2. So dy by dx is going to be equals to the denominator, boom, 2, times the differentiation of the numerator, 10x. I'm here, sorry. The denominator times the differentiation of the numerator is going to be 10x minus the numerator, which is 5x squared, over the differential of the denominator, which is 0, over the denominator squares. 2 squares. Ten times 2 is 20x minus 0 over 2. 2 is 4. 4 into itself 1, 4 into 20 goes 5. So I'm left with 5x. Let us see if what it is that we started off, it was 5x. See it here? You see the 5x?
Yes, sir.
Good job. So, and of course, when you differentiate 6x, what you get? 6. Don't.
Yes, sir.
Right.
And when you differentiate on a bugger when you know, watch me. When you differentiate a constant, what you get?
Zero.
0.
That's why you don't have anything more right here. So you see that?
Yes.
Yes, sir. Yeah, trick me again.
Can't trick you again. So that's what it is. So different. So integration is really the reverse process of differentiation. What I did here was to differentiate to prove to you what is happening here. So when you're integrating, you're just adding 1 to the power and dividing by the new power. Adding 1 to the power and dividing by the new power. That's all that you're doing. But remember also that when you're integrating an indefinite integral is an integral that has no limit to the elongated s. What is limit, sir? One number up on top and one number down on the bottom. All right? What we must include is our constant of integration, or plus c. Do now. If I ask you to integrate this, quick and fast. Quick and fast. Quick and fast. Matter of fact, this way they doing them something here. As opposed to differentiation, we have to show you working. For integration, just write down your answer. You write your answer down. None of long workout business. You just write down your answer and say, "Ropes, I eat this."
Sorry.
Yo,
Nothing I realize a thing.
go ahead.
Like in the first example, very good.
Mm-hmm.
I realize is that it's in an order. So if I go from 3 to 1 and then 0.
Very good. So that's how we do it. Sometimes they do it like that, and there are times when them give you what you pass up. But remember now, I'm only how we call it, not integrating. I'm only introducing this to you here now, and then now you know. Oh, come on, don't do this. And then at some point in time, I can mix up, and give you things into many different formats. But yes, your observation is on point. Your observation is on point. All right, go ahead for me, please. Matter of fact, I shouldn't even go ahead. I should be asking you what's the answer when I differentiate, when I integrate, sorry, 5x to the 4.
Respect the answer, so
Sir, sir, it's I have 5x to the 4 over 4,
Yeah, man, very good. I just
4x to the
4x to the
4x to the 3 over 3,
uh-huh.
2x to the 2 over 2
Uh-huh.
plus 3x
over
Am
1.
I,
over 1.
am I,
Yeah,
am I finished?
3x over 1.
Am I finished? Are you done?
Plus C.
You have to
Plus C.
the plus
Plus,
C.
Plus C.
yeah, plus the letter.
You must have your constant of integration. Yes, 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 yes. So what it is that we have right here is this. 5x to the 4th over 4 plus 4x squared over well, may I tell you one thing for sure, another penny love give me problem enough. 4x cubed over 3 plus 2x squared over 2 plus 3x plus c. If you don't give me a plus c, you are off. If you don't give me a plus c, you are off. I must have the plus C. And I want to see the plus C. If the plus C is not there, you're off. If the plus C is not there, you're off. Are we good with that?
Yes, sir.
You sure?
Sir, I know there's a lot more coming, but right now I'm good.
You know a lot more coming, but what?
I'm good right now.
You're good right now. All right. You see, me no like how you love style me, you know. Like me, just a butter on up to just come drop it. But never mind, keep it up. No man, it's not bad. It's not bad. I promise you, it's really not bad. It's really not bad. All right, let's go.
Question.
Yes, go ahead, Papa.
Between this and stationary points, which one worse?
You said worse. Why never said better? I'm not answering that question. Come, rephrase the question. You said worse.
Between this and stationary points, which one better?
Which is better? All right.
Yeah.
Stationary point gives quite a bit of questions. I mean, quite a bit of marks. The integration, they may give you like a series of questions to integrate. So they will maybe give you like 2 questions to integrate, and those 2 questions will amount to about 5 marks. Or so, yeah. Or sometimes they may give you 1 question. Okay, so if they give you an indefinite integral, the indefinite integral will be for like about 7 marks. And then now they will give you a second question, maybe a definite integral now, and they give it for 8 marks. So the 2 questions will come to 15 marks. So what I'm saying to you is don't expect to get a question on stationary points and integration together, because these are 2 big mark questions. So they won't give you 1 question to integrate. As I said before, they will give you 1 question to integrate for about 7 marks or 6 marks or 5 marks, and the other one for about 6 marks or 7 marks. You know, so it's anywhere between 12 and 15 marks you can get for just 2 integration questions. All right, and then now if you get something like that, then can fling another 50-mark question for you with something else. And that 50-mark question could be, we call it now, out of the 50 marks, you can get a 10-mark question for wait name again. What is something name what we do again? Jeez and peas. I can't believe the teacher can't remember. Piecewise function, right? By the way, did we do piecewise function?
Yes, sir.
Good. So you can
Yeah,
get
I think we did do it.
yeah, so you can get a piecewise function for 10 marks. So right there and then you have 25 marks, and then them find a 5-mark question. Them can get a differentiation question for 5 marks. And that's a whole question in and of itself. That's a whole question, 30-mark question in and of itself. All right, so that's what it is. Let's go. Let me give you a third one. Read out the answer for me, please. Don't write it, just tell me. Read the answer for me, please. The answer is
12 over
12
12x8
x 8 over 8.
Plus
15x to the
15x7.
7 over 7. Well, I look like negative.
What series are A that or X?
It's an X,
Sir,
but
that's
it's an American X.
No,
sir, that look like N.
No, sir, I can't read that.
Yeah, we'll fix up that, you know, sir.
But look like N. You see N point is something. Sure, that's good,
yes,
man.
even the 15n raised to 6.
So the one Maya, I didn't know got taste nice tonight, you know.
Well, you have more n's in the
Sir, that
equation.
look like 200 E, sir.
So we have work for dinner, sir.
Sir, don't like correction, you know.
That does work for the handwriting, no?
Sure, the time I spend right there, they can fix it 200 E.
Hey.
Oh, goodness. Oh, Lord, I love it.
Him just
Or
unruly.
you know, and I was a good teacher until I met this class, you know. Until I met this class. All right, let's go. It's always good to have fun. All right, let's go. All right, so now this is when I'm now giving 5x.
5x to the 2 over
Square
2
square over 2
Plus
2x
plus
2x
2x over 1.
plus C.
Okay. If I don't write the over 1, would I be wrong?
No,
No,
sir,
sir.
it shouldn't be.
Okay, good job. Now I'm going to show you something here that I didn't do in the first part that I want you always to do. You see, in the first one, you're going to always reduce it. So in this one, you will see 4 into 12 goes 3 times, and 4 into 8 goes 2 times. So we can get 3 over 2x to the 8. So always reduce your integrals. That's all. That's it. That is it.
Sir,
Yes, please.
question.
Mm-hmm.
Could we get a case where the power is raised to a power? I don't know why. Yes.
Well, be careful of what you're asking.
I am not asking for it, I'm just asking
Yes, you can. You can. You can.
if that's ever a case.
Hold on a minute, please, guys. Hold on. Hold on a minute. Yes, guys. All right. So, somebody had a question just now, or before I muted, or are you guys
I
okay?
was
Or
just asking,
go
sir,
ahead. Go ahead. Go ahead.
if there, but you said I shouldn't.
Oh yeah. So what I was saying to you is that what I'm trying to do as I normally do is to give you the introduction to the topic. There are variations. So I'm going to tell you, you can have a negative power, you can have a positive power, you can have a fractional power. So, you know, but for now, seeing that I'm introducing the topic, I would just want to give you the positive powers and just build your confidence. And then, you know, as you go along, you can
Yes.
get, yeah. But you see, I don't know if you recognize how it is that I teach. Nigel always said to me that I give the easy questions first and then give the hard questions after. But no, that's really not it. I give you the basic stuff for you to be able to, you know, to grasp, to understand fundamentally what is happening there, and then now gradually increase the intensity. And then when the intensity is increased, then the truth of the matter is I can do anything with the question. Look at what I did with when I introduced the chain rule first, and then I introduced the product rule, and then I introduced the power rule, the chain rule, then the product rule, then the quotient rule. Then after a while, now I just started giving you questions with everything mix up in it. And then you must now decide, this is going to be a product, this is a quotient, this is a chain, this is a power rule, and you guys can work any question thereafter. So don't worry about it, you will be fine. All I'm saying to you is, when I give you the question, don't, as opposed to the differentiation where you have to write your many steps, especially the implicit that we just did, when you're doing the integration, you just get the question, write the question, the next line is going to be your answer. That's how we're going to work it. The next line will be your answer. Watch me. I'm going to give you a series of questions. Numero cuatro. Numero cuatro. Number 4. And this question is a question. I'm putting the question this way because somebody asked a question that, I see that you're going down, you're decreasing the power. So I'm mixing it up now to show you that it can come anywhere or anyhow. Come, work with me now. I'm integrating x to the 5th. What do I get?
X5.
Won't it be
X6 over 6.
Come on, guys. I want all of you to unmute and come talk to me next.
7 over
7?
7.
Over 7.
BMW, I deal with tonight.
Yeah, man. Come. Quick and fast.
And
What is this one?
the next one will be, I think,
Plus
What
half.
negative what?
-1. X to the -1.
Over negative.
Over, would it be over 1? No?
Over -1.
Yeah.
So is that correct? Is that x? So look at me if you agree with my answer.
Yes, sir.
Yes, sir.
Yeah, man. So remember now. So I based on the question that was asked, sir, I recognize, well, not a question, it was an observation. Sir, I'm observing that you move x to the 5th, then x to the 4th, then x to the 3rd, then x to the 1. Will it always be like that? No. The man then can mix it up and put x to the 5th first, as in this case, then x to the 6th, then whatever else, x to the minus something. Sir, minus, you add 1 to the power, and then you divide by 1. The new power. You add 1 to the power, and then divide by the new power. All right? Now, let me just draw your attention up here, so, based on what I just gave you. So we looked at rule number 3. I want us to look at now, and incidentally, we did rule number 1. We have been doing rule number 1. When I integrated the constant 6, I got 6x plus c. K is a constant, so the integral of a constant k is going to be kx plus c. Sir, we never did that. Okay, let me show you. Right here, so. The plus 6 right here, so, was a constant. And when I integrated the constant, I'm going to get the plus c. So the constant, and when I integrated it, I get plus c. So that's what this first one is saying. The first one is saying that the integral of a constant dx is going to be equals to kx, the constant times x plus c. So we looked at the rule. We looked at rule 1. Of course, we look at rule 3. Now, technically we did rule 2. But I want to do it in a different way to show you that we have actually done rule 2. Rule 4 is what I want to talk about now. For the mere fact that I just did, I just did the negative x to the negative 1. You notice what I gave you here was x to the negative 2. Where it is. I gave you just no x to the, oh, so much for my uniform name. I just give you x to the negative 2. It is fine. I can give you x to the negative of anything. And just add 1 to the power divided by the new power. You add 1 to the power divided by the new power. Now, hear me out now. Hear me out. You see, when x is specifically given or specifically raised to the negative 1 power, you can't add 1 to the power divided by the new power. And tell me why.
That will be 0, that will be a 1.
All right? I'm going to ask you a question. Tell me why I can't just add 1 to the power and divide by the new power when x is negative 1.
Oh, you can't divide by 0.
Thank you very much. Thank you very much.
Can I
You
repeat
can't
that?
divide. Tell her what I said a while ago, please.
Yes, please.
So basically, what's her say? If it's x raised to the negative 1, if we add 1 positive 1 to negative 1, we're going to get 0.
Yeah.
So if you divide anything by 0, you can't. So
Oh yeah, you can't divide by 0. So we keep
Right.
the next. Okay.
Right. So guess what? In a case like that, we are going to have the fourth law that comes up. You see, once we
Sir,
have
but question before you move on. I noticed right here, I know you gave us this thing before, but if you could reinforce that. You would change the sign, because if you had kept the positive sign there between where the x raised to negative 1 is, you would have had x raised to negative 1 over negative 1. And so what you said that thing called again, transverse or something like that. So I don't remember what it called. Sir, are you there?
I'm right here, but I just don't remember what you're talking about. It don't ring a
Sir,
bell.
because this, I don't know what it is or what it's called, why you don't put back the negative 1. So x minus negative 1 divided by negative 1.
Oh, I think I know what you're talking about.
Yeah.
I was talking about when I was talking about the I know what you're talking about, Lord Jesus. Rain trees. I know what you're talking about. It
Rain
shouldn't come
on
back to me.
trees.
Yeah, I know what you're talking about. But this one here though is yeah, I know what you're talking about. But it is so what it is that if I say 6 over 1, I really don't have to write the over 1 because 6 over
Right.
1 is really 6.
Mm-hmm.
Right. So that's why I did that. So this one here, instead of putting it over 1, all I did was also change the sign to a negative.
Right. Because when you multiplied 1, all of that by the negative sign, it will
Become the positive.
It will be
Very good.
okay. Mm-hmm.
Very good. Excellent. So
yeah, that's what I was trying to remember.
Yeah, man. So just remember now. So we're moving into the fourth law. I may not do all the laws tonight, because I want to give you in chunk sizes. So when you look at it, you'll remember now that we are looking at the negative, the x raised to the negative first power. Once you have something raised to the negative first power, what we're going to be doing is now talking about the logarithmic function. The ln function is a pop-up. You're going to look at the ln function. Let me go back up here and show you what it is. Once it is that you are integrating something that says x to the negative 1, look at what it has. X to the negative 1 dx. You can't add 1 to the power and divide by the new power, because if you do, you're going to get something that is undefined. So what you have to do is to say ln x plus c. Ln x plus c. So if I give you, say, 2x to the negative first power, it's going to become 2 over ln, 2 times 1 over x, or 2 ln x, because the integral of x to the negative first power is going to be ln x, the natural logarithm. And tell me why now. because I did that with you. When I differentiate
You
one
know,
of
sir, I was thinking about it earlier to ask because in when you gave the thing the log I can't say the pronoun
the logarithmic function, right?
the log that function.
Right.
You said, the differentiation of that is the function or the expression divided or 1 divided by that. So it would be 1.
Over
Yeah.
x.
And
Very
so in this case, since Siobhan mentioned that, this is like the inverse,
Very good.
it would,
Because
that's the,
it will be the same. Yeah. Because look at this, my love. X to the negative 1 is the same thing. Come on, 10. Jesus. X to the negative 1 is the same thing as 1 over x, talk truth.
Yeah.
Yeah, man. So when I differentiate ln x, I'm going to get 1 over x. 1 over x is the same thing as x to the negative 1. So the differential of x to the negative 1, so x to the negative first power is the same thing as 1 over x. See, I have it up top here. See it here? That's it. So x to the negative 1 is the same thing as 1 over x. X to the negative 1 is exactly the same thing as 1 over x. And when I differentiate 1 over x, I'm going to get ln x. Because, so when I differentiate 1 over x, I'm going to get ln x. And when I differentiate x to the negative 1, which is the same thing as 1 over x, I will get ln x. And when I differentiate ln x, I'm going to get 1 over x, which is the same thing as x to the minus 1. So it makes sense. Fair enough?
Yeah.
All right.
It's a lot, but yeah.
It is a lot. I'm not going to give anything more. I'm not going to overpower you with the stuff we went through.
I mean, it's almost time for the class.
Yeah. That's what I'm saying. So it is almost time, and I gave you 4 laws just now, and those 4 laws would be 4 good enough stopping to hold you for the weekend. To hold you for the weekend. Here the plan of action for me for Tuesday, God's willing, and not Tuesday, no, Wednesday, God's willing. Wednesday, God's willing is to go through the other rules, and then to mix it up a little bit with some more variations to the integration, with some more variations to the integration. Right? But you did well. You did well. I'm happy that I was able to start the integration. What I will do is, all right, so I'm not home now, but what I'll do is to generate some questions on integration and just send off. Remember, it's just easy 1, 2, 3 for you to just get on this practice, right? So I'm gonna see if I can get some of those and send off and see how best we can answer those.
Sir, we know you kind of get old and sometimes you don't remember, but please remember, and you're supposed to send the other thing, the rules for the differentiation.
I'm supposed to send the rules, right? So I'm not home yet. I should be home in another hour. Maya, please send me a message.
Sir.
So send me a message so I can send up the stuff to you.
All right.
All right. So big up yourselves. We will talk again on Wednesday.
Sure, it was a good little session.
Yeah, man. I love it, man. Nice to talk to session. All right, cool. Big up on yourself. We'll talk here.
All right, take care.
Cool.
Oh, sir.
Yes, please.
I just got a response from Dejani.
What time?
She's said she's really ill, like terribly sick. So that's why she didn't join today.
Oh, she is sick?
Yes.
Oh no.
Yes.
All right. All right. Give her my love and share the information.
Yes, definitely.
Oh, and share the information.
Yeah.
And share the information with her for me, please. All right. We'll talk.
And sir, there is another item from our last meeting. You're supposed to watch the video that I sent you. So
yeah. I saw it. And I'm going to try it. I'm going to try it. I promise you. Cool. All right. Later, guys.